Let vector u be defined by the components -3, 0, 0, and let vector v be defined by the components 0, 3, 0. Part A, compute the magnitude of the cross product u cross v. And part B asks us to sketch a graph of vector u, vector v, and the cross product. So to get us started here, let's first recall the equation for the cross product. And so we know if we are given a vector v in R3, defined by components u sub 1, u sub 2, u sub 3, and vector v defined by the components v sub 1, v sub 2, v sub 3, then the cross product of these two vectors, u cross v, can be determined using our 3x3 matrix here. So we have the first row is our unit vectors, the second row is the components of u, and the third row is the components of vector v. And this simplifies down to u sub 1 times v sub 3 minus u sub 3 times v sub 2 I hat minus u sub 1 times v sub 3 minus u sub 3 times v sub 1 j hat. We need a little bit more room. And then that's plus u sub 1 times v sub 2 minus u sub 2 times v sub 1 k hat. And so this is the formula for our cross product, which we're going to need here. So for part A, again, we're asked to find the magnitude or find the length of the cross product. So we need to do this in two parts. The first thing we need to do is find the cross product. So plugging in our given information, we have the cross product of u and v. So putting this into my 3x3 of I hat, j hat, k hat, and I have -3, 0, 0, and v is 0, 3, 0. And applying our cross product formula here, we have 0 multiplied by 0 minus 3 multiplied by 0, I hat, minus -3 multiplied by 0 minus 0 multiplied by 0, j hat, and running out of room again, plus -3 multiplied by +3 minus 0 multiplied by 0, k hat. So simplifying here, we can see we'll have 0 minus 0, we then have 0 minus 0, and then last but not least, we have -9 minus 0. And we can say, therefore, the cross product of vector u and vector v can be written as, or has the components 0 I hat plus 0 j hat minus 9 k hat. If we want to convert this to our component form, we have 0, 0, -9. And I'm even going to go take this a step further and write this as 9 multiplied by the vector 0, 0, minus 1. And the reason I'm keeping my negative in there is because I know that I want to find the magnitude next, which is the length. And we want our length to be positive. So we're ready to go ahead and compute the magnitude of our cross product. Or find the length. So we're using our distance formula, so I'm keeping that scalar 9 on the outside, multiplied by the square root of 0 squared plus 0 squared plus -1 squared. So we have 9 multiplied by the square root of 1, which is just 9. So part A, the length of our cross product here is 9 units long. And that is our beautiful final answer to part A. So now in part B, we want to sketch a graph. And we want to sketch vector u vector v, and the cross product, the vector for our cross product here. And we'll keep in mind we were given vector u as -3, 0, 0, which we know points in the negative x direction. We have vector v, which is 0, 3, 0, which we see points in the positive y direction. And we know this is happening because the only component here that's non-zero in u is our x component, and in vector v, the only non-zero component is 3 in the y direction, or y component. And then last but not least, we have the cross product, which we know is perpendicular to both u and v, which is 0, 0, -9. And this vector points in the negative z direction. So we have space, we have our z-axis, our x-axis, and then the y-axis. So let's say there. So plotting u and v first, we know u is in the negative x direction. So here is vector v from the origin to -3. We can write this as a column vector, -3, 0, 0. We then have vector v pointing in the positive y direction. So we'll say there is 3. And that's our vector v here, 0, 3, 0. And then last but not least, we want to plot or sketch the cross product u cross v. And we know it's going in the negative z direction. So we'll say right about there is -9. So this is our vector for the cross product of u and v, which has components 0, 0, -9. And just in looking at this, we can see that it's creating at right angle with these two vectors. And so that is our beautiful final answer here.